grade 10s. It's me, Megan, here on a beautiful Wednesday, and we're here to do grade 10 maths literacy. And of course, I can't just be here alone, so I've got my beautiful teacher Hayley here with me. How have you been?
I'm okay, you Megan. It's good to see you.
Thank you. Very well to see you. We haven't been together on a show, I can't even tell you since when.
Ages.
Forever. But yeah, just tell us what we're doing in a quick little scope.
Today we're going to be doing data handling and probability. We're going to be doing some exam questions for you grade 10s, so be ready. But I know Megan's got a lot to tell you about all the nitty-gritty that goes into the show.
Thank you, Hayley. So just in case you want to know, the show is proudly sponsored by the MTN SA Foundation and endorsed by the Department of Basic Education. Just wanted to let you know. And okay, so where to find me, if you're questioning, if you don't know where to find all the information, all you go is facebook.com. So you log into your Facebook and you type in Learn Extra with an X. And if you want to find me on Twitter, it's at Learn Extra. And then also please go and into the Curio competition. We want to get that going. And the passcode for that is Learn for all of them. Because where are we almost at, Hayley?
We're going to be learning.
Oh, wow.
But before we start, guys, you won't remember, the matrics out there might, but like 2 years ago when we first started with Facebook, I used to look at our numbers every single week.
Sure.
And we got so excited when we got to like 10,000 people. Then we had a huge party, it was 21,000.
Yeah.
And now what I want to see is that we are on 99,210 likes.
That's
and that
ridiculous.
is huge.
Awesome.
It's like absolutely awesome. But guys, we want to get it up to 100. So tell your friends and go into competitions, and all the information's on the website. But let's go on with our lesson.
Awesome.
So
Let's
we
get
find that
started.
lesson here. Right. So like I said earlier, we're going to be doing exam type questions on data handling and probability. Before I start, let's look at our challenge question. I'm going to give you the challenge question now. You've got the breaks to do it, because I'm hoping that you're listening to me when I'm teaching everything else. And I will do this with you in our last slot. So, first let's do this. We're going to be revising exam questions on data handling and probability. Well, that I've already said. So here's our question. What is the probability that when two dice are thrown at the same time, the sum of the values equals 8? Now, I'm only going to give you one little clue. The sum means we need to add them up. Only clue I'm giving you. And you're going to get the answer. I'm sure you are. So we're going to leave that at that. Let's see what our first question is. As I go along and I do these questions, I'm going to kind of revise, teach you. So I hope that I'm not going too fast, but if anything, you can get hold of me on Facebook, and Megan will let me know if they're questions.
I will do.
So question 1 says, a recent survey was done with 400 learners. Now, it's really important that we highlight numbers. So always highlight your numbers, kind of read the question, reread, and don't forget that information at the beginning of the question is really important. Now, I know everybody says that Maths Lit, there's so much reading, but there's a lot of key stuff in that, so don't just go to the questions. So there were 400 learners between the ages of 14 and 18. The researchers wanted to find out what teenagers mostly used their cell phones for. They asked the learners what they mostly used their cell phones for. So that was the question. So let's just highlight the question in a different color. So they asked the learners what they mostly used their cell phone for. And below now we have a pie chart of the results. So before I even go to the question, I'm going to look at the pie chart. So we've got cell phone usage by learner. We can see the pie. It's quite a dull pie, but a lot of information in it. So we can see we've got SMSs 32, internet 33, music 61, calls 41. And I want to make a note now. When we see a pie chart, we normally see percentage. So clearly this is not percentage, because just those two add up to over 100. So if I look at my 61 and 41. So my guess is if I had to add these all up, it would add up to my 400 learners. So that's just a thing that we need to look at. So always look at how did they label it. Did they use percentage? Did they use degrees? Or did they use numbers? And they carry on. So we've got social networking, games, please call me, photos, recordings, and that's basically what the 400 learners said. So let's see what kind of questions they want. How many learners mostly use their cell phone for listening to music? So we don't know how many. Now we've already decided that this number next to the title is actually the number. So now it's quite easy. All we need to do is find our music. So we look for music. There's music. And we can see that that is 61. So quite an easy way to start. That's 61 learners. Now remember, Mathslet's always got a reference. So don't just add the number 61. You're not going to be marked wrong for it. But what is it? 61 what? I always say to my class, not 61 smarties.
Yeah.
It's my favorite sentence. 61 learners. Right, then it said, according to the survey, what are cell phones used for most? So now we're looking for the biggest part of the pie. So when we go down and just visually look at it, we can see that that's quite big, and we can see that that's quite big, just looking at it. So if we compare, we've got social networking of 80 and photos of 72. So which is my biggest? It's my social network. What are cell phones used the most for? So now we add, it's our social network. Right, question 3 says, suggest how the researcher could improve the question that they asked of the learner. Now, I love this type of question. This is definitely a paper 2 type question because it is your own opinion. And what's so lovely about this type of question is it's very hard to mark you wrong, as long as you make sense. So anything that makes sense should actually give you both of the 2 marks. So now let's think about it. The question, we actually highlighted the question, was what they mostly use their cell phone for. So that was kind of the question. What do you use your phone for? Now, even you guys listening now, and if I had to ask this of another 400,000 teenagers, you're going to give me one answer. And that's kind of an opinion, because it's what you're thinking that you use your cell phone for. So you might say it's for social networking, checking Facebook, going on to the Learn Extra site.
Exactly.
You might say it's for phoning, but it's an opinion. It's kind of like, what do you think? And it'll be immediately one answer. Now, I know that most of us use our cell phones for more than one thing. So what we could actually do is say, let's not just ask for an opinion, let's actually check. And let's ask you to actually complete a table. Complete like a tally table almost. And every time you pick up your phone, what are you doing with it? And then you could have something like, I'm just going to go with SMS, your social media, etc., etc. Okay, calls. So if you phone somebody, and if you had to make a list, it would actually be more accurate, no longer an opinion. So if we had to say, well, okay, no, I SMS now, I went on social media again, I used the phone, and do that for 24 hours, or do that for an hour, or however long it is that they want to get the information. It would make the question a whole lot better. And it would also show that people use it for more than one thing, but then we could take it, it's not an opinion any longer. Does that make sense, Megan?
That makes sense, yeah.
So it's no longer an opinion, it's now actually fact, because we've got proof
Data.
behind it. But again, your opinion. So very hard to mark this wrong. Right, let's move on to the next question. So the next question says, what do 8% of the learners mostly use their cell phone for? So because we're looking for 8%, we need to find out how many that 8% is. So remember we started with 400 learners. So if I take 8% of 400, I will see how many answered that question. So let's get our calculator out. And we'll say 400 times by 8%. And I get 32. So I'm looking for 32 learners. But that's not my question. My question says what? It's what do these learners do? So now I'm looking for 32 of them. So let's go back to our pie chart and see where we can find 32 learners. So 32 learners is your SMS. So 8% use it for SMS. So therefore, it is SMS. Right, now we've answered the question. And guys, when you're doing exams, read your question, answer the question, go back and reread. Make sure that you actually have answered what they're asking. And also, you will pick up things like rounding off correctly, changing to a decimal, those kind of questions you will pick up in your second read. So that's good advice. Calculate the number of degrees that were used to draw the sector for social networking. And I'm glad this kind of question came up, because now we can discuss our pie charts. So, if we look at a pie chart, I don't think you will be given a pie chart to actually draw, but we need to understand a pie chart and we need to be able to calculate the degrees. I don't think they will physically ask you to draw it. They're going to ask you to estimate a pie chart though, and that I can show you now in a second as well. In my circle, I have 100%. I also have 360 degrees. So it is important to remember that the whole is 100%, and that is usually used, I'm going to add this here, this is usually used to label the chart. We usually label the pie chart with a percentage, and the degrees is used to draw it, and then you would need your protractor. So now, how are we going to calculate the number of degrees that were social networking? Well, let's go back up to social networking to see the number of people. So social networking was 80. So I'm going to go back to this question. Right, so I had 80 that used social media out of 400, and it's always your fraction, and it'll always be your small number over your big number, and I'm going to times that by 360 because I want to know how many degrees that is. And then on your calculator, get your calculator out. So we've got 80 divided by 400 times by 360, and I get 72 degrees. 72 degrees. Just for argument's sake, I just want to work out the percentage if we needed to label it. So I'm going to do the same calculation. I'm going to do it here. 80 divided by 400, and I'm going to times this by 100. So if we had to work out each one, we could. So let's do that. 80 divided by 400 times by 100. And we see that that's 20%. 20%. So now you can work out degrees and you can work out percentage. And what's also nice to know is that 100%, I'm going to move it over here, 100% is actually equal to 360 degrees. Whoops, 360 degrees. So in other words, 1% is actually equal to 3.6 degrees. And you could use that fact and actually just use it as a ratio. So a nice way of doing a calculation. Now I know we've got a question where we need to critically evaluate. I'm going to need some time. So what I think I'm going to do is I think I'm going to give you a little bit of a break. So go get something to drink. And before I do that, though, I'm handing over to Megan because I know she's got lots more to tell you. Competitions and things and cars.
Yes, cars and things. Okay. So guys, how this works, it's pretty simple. I'm going to explain it slowly to you just so you understand. What the competition is Safeway K53. So it's the Be a Bright Spark competition, because you're going to either win yourself, well, not either, but you could win yourself a Chevy Spark L. Can you imagine winning your car? Like,
that's
that
awesome.
Would be amazing. So all you have to do is like Safeway K53 on Facebook, and I told you how to find us on Facebook. We've already entered this all on Facebook, so if you can find us on Facebook, you'll know how to enter. But so all you do is like that Facebook page, you buy yourself a book, or you can buy the app from the Google Play or the Samsung Galaxy App Store. Very easy, very simple. And then you enter the competition, and voila, you could win yourself. The competition only has 3 days left for the first car.
Enter.
Yes, so enter, and just remember it's Safeway K53. But I'll talk more about it as we go along. But I think it's time you go have a break, so just stretch your legs, jump up and down, and we'll be back right after the break. Welcome back, grade 10s. You're here on Mindset Learn Extra, doing exam school revision with me, Megs, and Haley with maths literacy. So we had a challenge question in the beginning of the show, and needless to say, I did have a look at your answers, and I asked Haley if they were right, and unfortunately for Everil, Moss, and Ivy, she says, please go try again. So just try again, post again your answers, then I'll tell you if you're right or wrong, and at the end, we'll work through it, okay?
And
Right?
don't give up.
And don't give up.
Don't give up. Okay, so like I said to you, we want to critically evaluate. So let's go back to the work. Right, so we said critically evaluate the graph that was drawn for the data collected. Again, this is kind of your opinion. So I'm going to go back to the graph. Do you remember right in the beginning when I started with the graph, I said to you, it's kind of strange that they have these numbers. So the first thing I would say is if you're going to use a pie chart, you must add the percentages. And the reason for that is if I say to you calls is 41, it doesn't really mean anything. Whereas if I say calls is 10%, more or less, it makes more sense. It's more meaningful. We can understand 10%. We worked out the percentage for social networking as 20%. We can make sense of that number. So that's the first thing I don't like about this graph, is that they actually use the numbers rather than a percentage. So whenever you're drawing your own graph, it's important that your pie chart has percentages. Then I'm going to actually delete some of these. Going to just erase some of these notes, some of these things. And I want us to look at this graph again. Right, so let's get back to my pen. I think I was using a yellow. There are a lot of pies to this pie chart. There are a lot of tiny little things. So it's very hard just looking at it to find out which is the highest. Remember when we were looking for the highest, we said social networking, maybe photos, and we had to then go back to the numbers. So there's no order. So I would suggest if you're going to draw a pie with lots of different categories, that you actually do it in order. And what I mean is start at the top and draw your biggest to smallest. Okay, so let's make those notes. We're going to, first of all, we needed to label with percentages. Then because there are so many pies, we want to do them in order. And what I mean is basically starting from the biggest to smaller, carry on going around, okay? But hold on a second. We want to know how good this graph was. Now, I don't think a pie chart was good at all for this. I would have said, well, let's try a different graph totally. Why don't we use a bar graph? Because if I had to put that information in a bar graph, it would be so much easier to see. Okay, with my pen going down. It would be so much easier to see the different sizes. So my social media was 80 and 72 was my photos, and I can immediately see it, and then I'll also be able to pick up the smaller ones. So it makes it easier to actually see when there's a lot of categories in a bar graph. So there you go, we've answered that question. We've kind of critically evaluated it, and again, your opinion can't really mark it wrong as long as you make sense. Let's tell you what, let's try a different question, different kind of graph, and see what we have here. So the graph below shows the number of runs the Proteas scored in each over. Oops, how crooked was that? Okay.
Points a bit
Try that
squiggly
again.
there.
It's very squiggly. Right. So we want to know the Proteas scored in each over in a cricket match played against New Zealand. So when we look at our graph, again, I'm going to analyze this graph first. I'm going to tell you a few things that I have problems with, but this graph was taken straight out of the internet from one of the cricket websites.
Oh, wow. Okay.
So this is the kind of thing that we as maths lit people, maths litters, that's what I was going to say, we can critically evaluate graphs, and we can look at things and actually see whether they're right or wrong and understanding. So we have the played against New Zealand. We've got runs per over, and you can see each one of these, and then we've got over numbers. few things to point out. Oh, and these black dots, I'm going to make them white dots. No, see if I can. No, I'm not going to colour them in. That's not going to work. I'm going to try. I think those are your wickets. Right. So we've got our over numbers, and what are my issues? First of all, let's have a look at the x-axis. So I've got from 0 to 10, 10 to 20, 20 to 29. Why did we not go to 30? So I have an issue with 10 to 20 to 29, and then to 39 and 49. Now, there are 50 overs in a match, so let's get that out of the way. We didn't need to go to 50 because clearly the South Africans were batting second, and they completed and beat New Zealand in the 49th over. So we didn't need to go 50. And it's not that they didn't score runs, the game ended at 49. And that's why they have made that 49. But then we had a gap somewhere where there's 9. So be careful. I would have rather said 50 and maybe like blocked it out as it wasn't played. That would have been mathematically better. Then the other thing this graph does is it goes from 0 to 3, 3 to 6, and then 6 to 8. So remember when you draw in your graphs that you have to have the same amount, your scale has to be the same for the same blocks. So we should have gone 3, 6, 9, and then 12, but we didn't. We went 8, then we went 11, and then 14. So make sure your scale is correct. It also makes it a little bit harder to read the graph because say between 0 and 3, we don't have lines in between, but we can see that that is 1, that clearly is 2, and then that's 3. So the graph, I have a few issues with the graph, but let's use it to carry on answering some questions. Now, where did this come from? I think it came from my shirt. Okay. So, in which over did the Proteas score the most runs? And that's easy enough to see. You can use your ruler. This one's easy. Just find out which is the highest. That's the highest. Which over is it? Well, we know that that's the 49th over, so that must be the 48th. So that's the 48th over. How's my tea? In which over did the Proteas score no runs at all? Now we go back to my graph, and where did we score no runs? Well, we'll be on 0, and it was only at this point here where we scored no runs. Carry on along the graph. Everywhere else, there's at least 1 run. So that was in over 2. So in the second. Now remember, the numbers tend to get a bit confusing. So we started at 0, but that's the first over. Then second, third, etc., etc. So it might be worth your while to even put in like numbers in between. It might make sense. So between 10 and 20. How many overs did the Proteas score 6 runs or more? So that's again an easy question to do. So what I'm going to do is I'm actually going to take a line and I'm going to draw a line on 6. And you could do this with your ruler. There's my 6. And now all I need to see is how many are over my line. So go back to my pen, but we're in green. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they're 11. And now these are easy questions, guys, and these are the kind of questions you will get. So this is 11 overs. These are the kind of questions you will get in a paper 1 type question. So it's a paper 1 question because it is fairly easy, but it's a skill of being able to read your graphs. So like, go back and practice the graphs that you've done over the year. Practice going over past papers, your papers that you've done before. Just make sure you can read a graph. Go onto the website. Go find some cricket graphs. Go see if you can make sense of them. So that was above 6. What's our next question? What is the mode for the number of runs scored per over? Mode, now let's just revise. What is mode? So your mode is the most. So So the mode is your most. So now we need to go back to our graph and see, well, how many of each did we score? So what I would actually suggest you do is almost kind of draw a little bit of a tally table. Okay, and let's see, well, we know we only had 1 0. How many ones have we got? Well, let's look at it. We got 1, 2, 3. So I would kind of, for this, do a little bit of a tally table and say, well, naught, we know we had 1. 1, I've just counted 3. 2, and we can go back and count those. Okay? And we carry on. So 2, we've got 1, 2, 3, 4. But as I'm doing this, I'm noticing that there are a lot of 3s. So I think your modal class is actually 3. But this is the kind of thing that you would need to do with a little bit more mathematics, should I say. A little bit more mathematics. Right. So 3 is, because we've got, let's just count the 3s. That'll give me, I'm going to change colors here, so I've got a different color. Right, there's 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 9 with 3s. And that is my modal class. Whoops. I'll go down. So 3, there was 9. So therefore, 3 runs is the mode. Okay. Like I say, just do a little bit more mathematics. What is the mean for the number of runs per over for the first 5 overs? Oh, that was quite a nice question. They could have asked us for the whole match. So 5 overs, and now mean, this definition, what color did I use the definition? Oh, I'll do it in yellow. What does mean mean? Mean is what we in everyday language call average. And why do I say everyday? Because we discuss it as an average in our everyday language, but in actual fact, mean, median, and mode are all 3 averages. So we've got to be careful with the word average. So mean is when we add them all up, and divide by how many. So straight away, I can see for this, we divide by how many? I'm going to be dividing by 5 because they asked me for the average, for the mean over 5 overs. So let's go to our first 5 overs and see how many there were. Right. Are you going to remember the numbers, Megan?
Okay.
Okay. It's 11,
Yep.
0, 3, 1, 2. That's 1, 2, 3, 4, 5.
Yep.
So now Megan's got our numbers for us. We're going to do them on the side. It was 11,
0,
0,
3,
3,
1,
1,
2.
2. Okay. Don't forget, in statistics, in data handling, 0 is really important. It is not nothing. It is a value because it wasn't over where they scored no runs. So it really is important to our average, and we're going to add those up. I don't think we need a calculator because it's 11, 14, 15, 16, 17. Maybe I should check that, especially on TV. So I'm going to check it. So it was 11 plus, what did we have? Plus 0.
Yeah.
Plus
3.
3 plus 1
1
plus
plus
2. It was 17. My
perfect.
maths wasn't too bad. I always think to myself, like when I'm sitting on TV, if I make a mistake, that's like anyway, don't make a mistake. Right, we're going to divide it by 5. So 17 divided by 5 to get our answer, and it is 3,4. 3,4, but what is it? 3,4? It was 3,4 runs. So remember our reference again. Right. Next question says, during this match, what was the probability that the batsman would hit more than 8 runs in and over for South Africa? Now, my probability is always written as my favorable event, and this might help you actually with the challenge question. Favorable event out of total possible events. So, favorable out of total possible. So my favorable means that it happened, that they scored over 8. So we're looking at over 8, more than 8. So we're looking at anything that's above 8. And out of our total possible, well, remember they played 49 overs. So it is out of 49. So now we're going to go back to our graph and see how many times they scored over 8. And what I'm actually going to do is I'm going to grab that and move that up to 8. If I can move it to 8. Right, and then I can count how many were above. So now I think color, that should work. Right, I've got 1, 2, 3, 4. So it was 4. So it became 4 out of 49. Now what's important about probability is you can leave your answer like that. If they don't ask you for it any other way. Probability can be written as a fraction. It can be written as a decimal. And it can be written as a percentage. So if they ask you for a decimal, what we're going to do is we're going to take our calculator and we're going to say, well, it was 4 divided by 49 equals, there's my decimal, 0.08.
Would they round it? How would they round
They
it?
would round to 2 decimal places. I would go with 0.08. It was a good question. Thanks, Megan.
Awesome.
And as a percentage, we would take that decimal and times it by 100. And then again, round it to 2 decimal places, so it would be 8.16. But if they don't ask you, you don't have to do anything. You can leave it like that. And in actual fact, even if you have something where you can simplify it, you don't need to simplify it. You can leave it as the fraction as it is. Just by the mere definition. It's your favorable outcome out of your total possible. So we can leave it like that. Do you think I should go on to start the next question? Or do you think we should give them a break?
You decide, ma'am.
I tell you what, I'm going to give you guys a break. So I know that we've still got time now, but take the break. Let's rather start the question and do the whole question in one.
Okay. Yes,
That
that
sounds-
makes sense. So guys, just go get some water, refresh your brain, put your pens, your pencils down, and let's just go for a teeny tiny break. We'll see you afterwards. Welcome back, grade 10s. You're here on Learn Extra Live, doing some maths literacy for exam school revision. So, I hope you had a good break. I know we gave you a little bit of a break just to stretch your brain, think, indulge in all the information. But I think now it's time to get back to it, and Haley's going to take you through the next question.
Perfect. While we had the break, I decided that I'm going to leave question 3. If we've got time, I'm going to come back to question 3. I'm going to do question 4, then we'll do the challenge question, and then we'll probably come back.
Cool.
I'm sure we'll have time. So, question 4 says, right, Miss Manana is a mathematical literacy teacher at Fundakile High School. Can't pronounce. Okay. Her learners wrote a test out of 100 and obtained the following marks. Study the given data and answer the questions that follow. So that's quite easy. We've got data. Before we start reading, we're looking at our data. Now, we have marks. They're out of 100, so we know their percentages. And the first thing I need to look for is there an order? That's the first thing I always look for if I have data, because I know for certain things I need to have them in order. So I'm looking at these and I'm seeing that they are. We go from 40, we go bigger, right up until 85. Paper 1 should be in order. Paper 2, you're going to have to order yourself. So that's important to remember. Right, so now that I have it in order, I'm going to go back and read the question. So calculate the range of the marks. And that's great because we didn't do range earlier. So your range is, its definition for range, is your highest minus your lowest. And because it is in order, actually quite an easy question. 85 is my highest, 40 is my lowest. So I've got 85 minus 40. Don't think I need a calculator for that. 45. And we can add the percentage, because remember this was out of 100. So 45% or 45 marks, which is 45. This is one case where you can actually leave off your units. What is the median mark for the set of marks? So again, definition, your median is your middle number but very, very, very important. I'm going to do it in yellow. It must be in order. Must be in order. Now, the order doesn't matter. Must. It doesn't matter if it's from highest to lowest or lowest to highest. It really doesn't matter, but we need them in order. So we go back to our values. And what you can do is, if you'd like, is you can cross them out. You kind of like go and cross out there. So you could do it that way, and kind of with your hands or your fingers, pens, whatever, work out which is the middle. You can count them. So if we've got 2, 4, 6, 8, 10, we've got 20 values. So I now need 10 on either side. So my 10th value is 57. My 11th value is 58. Before I carry on with that, what is important if you're rewriting the list, because you've had to put them in order, please check that you've got the same number that were in the exam, because really easy to leave a number out. So if there were 12 values, you need to have 12 values. If there were 20, you need to have 20. Just make sure that such a careless little mistake can make a huge difference. Right, median is a middle number. We have two numbers. So what are we going to do? We've got 57 and we've got 58. So we add these two and then we divide by 2. Now, when we do this calculation, very important that we actually get the number that is in between the two. So the number in between here is 57.5. But I want to actually take out a calculator, and especially if you're not using a scientific calculator, I want to point out that if you say 57 plus 58 divided by 2, the calculator is going to BODMAS, and you're going to get a number that's bigger than both. That is not in the middle. So what we have to do to alleviate that, let's go back to that, is we have to plus 58 equals and then divide by 2. So you must make sure that your number is in the middle. Perfect. Let's see what the next question is. It says find the value of Q1 and Q3. Go back to my data. So my Q2 was there, and we said it was 57.5. When I calculate Q1, it's the middle of the lower half, and I exclude that number. But because it's not a specific number, I'm including 57. So I'm going to work out the number from that. I'm going to take a different color, right, and cross them out. I'll do them cross this time. That's 2, that's 3, that's 4, that's 5. So it's in the middle of those two. We're going to add them up and divide. So Q1 is there. Q1, I don't remember what those numbers were. 50 and 52, I think. 50 and 52. So 50 plus 52 divided by 2. That doesn't look like a 5. Let's just fix that up. And you can get your calculator out. You have 50 plus 52 equals, divide by 2. We see that's 51. Alternatively, it was quite easy to see which number was in the middle. And Q3, we're going to do the same thing. Q3 is the middle between those two. We need 5 on either side. So 65 plus 68. Plus 68 divided by 2. A little bit harder than to do in our heads. Divided by 2 is 66.5. So there's a number in between, so I'm happy that that is Q3. And then finally it asks you to calculate the interquartile range for the marks. Interquartile range, otherwise known as RQR, okay, is actually Q3 minus Q1. What's really nice about this interquartile range is that it shows you the values in the middle 50%. I'm going to draw that in a second. Let's just do the calculation. It was 61.5 minus, 66.5 minus 51. We got our calculator. 66.5 minus 51. And we get an answer of 15.5. So I tell you what, before we go on to the next question, I want to just show us our value. If we looked at our values, that's my smallest, that's my largest. There's Q2, there's say Q1, and that's Q3. Now they don't have to be equally apart. This basically, my interquartile ranges from there to there, gives me 50% of my values that are closest to the median. And then leaving us with 25% on the end and 25% on that end. So this shows you 50% of the values that are closest to the middle. And then it says, what percentage of learners scored more than 65? So let's go get that question. More than 65. Well, count them. We've got 1, 2, 3, 4, 5. So it's 5. And how many learners were there? 5 out of 20 times 100. And that's easy enough to actually calculate. And get our calculators out. 5 divided by 20 times 100. 25%. Right. Going to go on to the challenge question, just so that we don't not get it in.
I have
Then
to
I'll
tell you something though.
Tell me something.
Someone got the answer.
Yay, who was it?
I will. Oh, here we go. It's going to go up. It is. Oh, she's got a beautiful name. Veritiella.
Veritiella. Well done to you. But for everybody else that's been struggling,
Sorry. Almost gave it away.
reread our question. Okay, so what's the probability that when 2 dice are thrown at the same time, the sum means we add up the values equal to 8? So what we need to do is we need to say, well, we've got 6 sides to each dice, and we need to add them up. So like if the one lands on the 1, to get 8, can I get a 7 on the other? No, I can't, because it goes 1 to 6. So the easiest way to actually work this out is actually to draw up this little contingency table. So I'm going to do this as dice 1. I'm going to see if I can find a highlighter. Okay, well, I don't know where, if I got a, never mind, won't find for a highlighter. Let's just do colour. So that's not erase it. Okay.
Board's fighting with us.
Board's fighting with us,
Sorry.
totally. Let's undo.
Just undo.
Undo. Okay, so I'm going to do that, make that purple. So that's the first dice. And the second one I'm going to make yellow. And in each one of these blocks, I'm going to say, well, okay, if my yellow landed on 1 and my purple landed on 1, if I add them up, I end up with, okay, I end up with
There we go.
2. Yay. Okay. And etc. So if my yellow lands on 1 and 2, I've got 3 and 4 and 5 and 6 and 7. And so far I haven't found one that actually has an 8. But can you see how easy it is with doing this contingency table? I'm going to actually open the whole contingency table. We actually get all the information. So let's go. That lands on 4 and 1 is 5. So I'm going to see, where are my 8s? Okay, so I hope everybody's following the contingency table.
Land also goes in like a pattern.
It does go in a pattern. It's a
Awesome.
standing pattern. So now we have how many possibilities? And remember, our probability was our favorable out of our total. Whoops. Go back to that. I need a pen to draw. So it was my favorable out of my total. So how many totals do I have? I actually have 6 across and 6 down. I've got 36 possible outcomes. Now, how many times did it land on 8? So we need to find our 8s. So there's 1, there's 2, there's 3, 4, and 5. So can you see how using a contingency table actually makes it so easy for us to see that the answer was 5 out of 36. And I could use this table for a whole lot of answers and a whole lot of questions.
It's really cool.
And what's important to note in this particular instance is that it made a difference if we had yellow 6. So I'm just going to go, this was a yellow 6 and a purple 2, whereas this one was a purple 6 and a yellow 2. So even though they landed on 2 and 6, those are two different outcomes. So we can have 6 and 2 and 2 and 6, and there are two different outcomes. So the contingency table is actually perfect for showing you how that works.
It's awesome.
So we've got the and I can't remember the name. So well done to
Vivi Yellow. Yeah.
that's the one.
Sure.
But now I'm going to go back to question 3.
Cool.
And I'm not going to do everything on question 3. I'm actually going to just show you question 3. I'm going to read some of it, and we're going to discuss a few things. So the maternity section of the South African hospitals were a hive of activity with a total of 320 babies delivered on New Year's Day in 2014. And this was told to us on the SABC TV News. Right, the data has been recorded in the table below. So we have a table, and this is almost like a contingency table. Look at that. We've got our provinces. Okay, we've only got a few of our provinces, so 2, 4, 6, 7 of our provinces, and the number of babies born. So we've got Eastern Cape, 43, Limpopo, etc., etc. And if we add this up, it should add up to our 320 babies. Now, what I want to actually do before we finish the show is I'm going to show you, they ask you to draw a bar graph. And I just want to point out, bar graph is one that has spaces. Do you know how my kids
histogram
remember the
has
bars?
together.
Histograms together. Now, my bars, I always think about it as sitting behind security bars. There's spaces and you can see through it. One of my kids said to me the other day, it's like going to a bar and having drinks. You don't have your drinks all together. You have a space between them, and you have a space between chairs in a bar.
Yeah.
So, okay, there are spaces. Remember, you must have a space first. Histogram is for continuous information where there's no gap, and it's kind of like it goes in order, and that would be a histogram. So those are the differences. But I think we nearly finished the show. I'm going to say goodbye. Good luck, grade 10s, and I hope that somebody that's been watching today wins the car. I know you're going to tell them all about that. Good luck. Practice, practice, practice.
Thank you, Haley. Thank you, guys. I'm just going to quickly end off our show with, again, the K53. It's Safeway K53. How you enter the competition, you like the Safeway K53 on Facebook, and that's facebook.com/learn extra to get the link on all of this. You can buy this book. It's really awesome. Don't you remember using it for your learners or your license, Haley?
Yeah,
Yes,
go a while ago.
back
Way back when.
But it's really helpful. It has really awesome things. It's really relevant to what we need to do. So you just do that, and you can also get it on the Google Play or the Samsung Galaxy App Store. Very easy. Then you enter the competition. You have 3 days left, grade 10. 3 days left to win yourself a Chevy Spark L. And that's really all we have to say for today. But thank you so much, grade 10s. It's been amazing being with you again. Maths literacy, good luck. I know exams are hard. I know they are stressful, but I promise you can get through them. I'm luckily finished with my exams. So have a great evening. That's love from me to you. Cheers, grade 10.